Good evening, everyone. Welcome to another Planetarium live stream. Let everybody start gathering here for a moment. Welcome, welcome. Happy New Year, everybody. Hope you all had a lovely New Year and are staying warm through this very chilly few first days of the year. Let's check in, see how we're doing. All right, I've got a few people watching. Awesome. Let's go ahead and get this show on the road then. Welcome, everybody. I am Patrick Hess, the Planetarium Manager at Union Station, and thanks for joining us tonight for our 78th live stream. This is now the third year we've been doing these, which is crazy to think about. I want to thank our supporting sponsor, MRI Global, for keeping our live streams and many other programs at Union Station going. We appreciate their support. And thank you to all of our watchers tonight. This is a live stream. It is January 3rd, 2022 at 6 p.m. Central Time. So if you're watching live, let us know in the comments. This is live and I want it to be interactive, so I'd love to answer any of your questions you might have throughout the stream. I love hearing where you're watching from, so post in the comments where you're watching from and we'll definitely give you a shout out. Yeah, thank you all for joining us. We've got Tammy, one of our top fans, longtime watchers, who says, Happy New Year from very cold Iowa. It's very cold in Kansas City as well, Tammy. Great to see you today. Rachel McDonald's chiming in as well. Wow, 78 streams. Indeed, Rachel's pretty amazing. By the way, if this is your first time tuning in, welcome. I hope you enjoyed tonight's stream. It should be a lot of fun. We're going to do a little seasonal star tour. I'm going to show you what's up in our January skies, and we'll also do a little preview of 2022 celestial happenings going on this year. And then I'm also going to go over the past month's worth of news in astronomy and space exploration. If this is your first time tuning in, don't worry, because all of our past live streams, all 77 of them, can be found on our YouTube channel, youtube.com/KC Planetarium. And you can find all of our past streams there. It looks a little something like this. So check us out, like and subscribe there, and you can watch all of our past streams. I've organized them into playlists. We have done a bunch of deep dive program topics, hour-long presentations, all about different aspects of astronomy. And you can see 46 of them. Holy guacamole. Done a bunch of different sky cultures from around the world, different deep dives into science fiction, book, film, and television. And then we've done a grand tour of the solar system, making stops at all major planets, dwarf planets, moons, comets, satellites, all those things, you name it. So youtube.com/KC Planetarium. Be sure to like and subscribe over there. We upload all of our past streams there. If you're a returning watcher, well, of course, thank you so much for your support and your returning viewership. Wow, a lot of people in the comments. This is so amazing. I love seeing everybody chiming in. Susie says hi from Overland Park. Hi, Susie. Thanks for watching tonight. Got Deborah says Happy New Year. Right back at you, Deborah. Brian as well. Happy New Year. Christopher says hi from Prairie Village, Kansas. Great to see you, Christopher. Thanks for watching. Charlene, watching from Indiana. Ira says, a good friend of mine follows the stars. Venus and Mars are all right tonight. Well, we'll definitely touch on those, Ira. Don't worry. Susie says, it's my first time. I just moved into the area. Awesome, Susie. Welcome to the area. I hope Kansas City's treating you well. And I hope you enjoyed tonight's live stream. Got Deborah watching Kansas and Missouri in the house both. Wow. And Sherry says, Happy New Year. Right back at you, Sherry. Thanks for watching tonight. And Eric, one of our longtime watchers, says, howdy from Lenexa. Well, hey, Eric. Thanks for tuning in. All right. Well, we've got a lot of fun stuff to cover today, so let's dive in. Oh, a couple quick little news updates. The planetarium is closed to the public right now, just for the week, through Friday, but we'll be reopening on Saturday with a brand new schedule. That will be Tuesday through Sunday, our schedule then. We've got some fan favorite shows returning into the lineup, such as Phantom of the Universe, which is a deep dive into dark matter. And we've got Mars 1001, Journey to the Red Planet. And of course, our live star tour and other fan favorites like Big Bird's Adventure and Magic Treehouse will be available as well. Laser shows will be coming back pretty soon too, so be sure to head on over to the Planetarium's Facebook page. That's facebook.com/KC Planetarium. And if you're not subscribed there, be sure to do that, because we'll post all of the laser show updates and other schedule updates there as well. Catherine says hi from Peculiar. Thanks for watching, Catherine. And says hey from Prairie Village. Thanks for watching. And Eric says the Twilight Zone episode is my favorite. Yes, the Halloween episode in 2020, I did a deep dive into space mysteries, which I did in black and white, wearing a tuxedo and mimicking the great Rod Serling. and the Twilight Zone. So be sure to check that one out. That was a ton of fun. Again, youtube.com/Casey Planetarium. Stacy watching from Lake of the Ozarks. Oh my gosh, so many people tuning in. I really love this interaction. While you're watching, be sure to think of good questions to ask as well. Well, we're going to dive right in, and we are going to check out, we're going to start with some 2022 highlights. Let's see what's going to be up in our night sky this year. And this is one of my favorite websites, Sea and Sky, that presents a sort of a very basic roundup of everything that goes on in the night sky throughout the year. It'll track things like new moons and full moons, as well as some meteor showers. This is a great reference that'll tell you how good a meteor shower is. The quadrantids is happening tonight and tomorrow, with a peak of about 40 per hour, which isn't amazing, but it could be a good time to look for this meteor shower since the moon is very thin right now. And the meteors will radiate from the constellation Pleiades. Well, let's keep scrolling down here. A lot of positions of planets, basically when they're at the highest in the sky, so the best time to view planets like Mercury, which is hard to spot. But I wanted to fast forward here and point out a couple good meteor showers, as well as other exciting celestial events like solar eclipses. So, for example, we have this partial solar eclipse, which will happen in April. Now, this one may not be visible from here. In fact, this one definitely won't be. NASA provides a great diagram showing us the path of the eclipse, and this one will be very far south, so we will probably not see that here in Kansas City, but this will track where it's visible. If you happen to be in the southeast Pacific Ocean in April, you may catch this partial eclipse. The Eta Aquarids meteor shower is going to be an above average shower. Mark your calendars there, May 6th. This will be a southern hemisphere meteor shower, though, so we might not see it up here. Ooh, a total lunar eclipse. This one should be good throughout North America. So this will be on May 16th, and the moon will pass all the way through the path or the shadow of the Earth, causing it to turn bright red. We call it a blood moon. And this one will be visible here in Kansas City. So mark your calendars there, May 16th. Depending on the time that this takes place, too, we may try to do a viewing event at Union Station as well, which I always love doing. It's been a couple years since we've done those. Well, we can set up a telescope so you can see this up close. The greatest eclipse will be at 4 o'clock Universal Time, which will be, let's do some quick, where I am, UTC. So that'll be about 10 p.m. Actually, that'll be perfect. So this one will be in the early evening. So mark your calendars, May 16th. I'm calling it now. We're going to do a viewing event at Union Station with a telescope. So that should be pretty spectacular. Let's continue on. We got a supermoon in June. There tend to be 3 supermoons every year, and they tend to be close, grouped together. So you see this full moon on June 14th will be a supermoon. The moon will appear a little bit larger and a lot brighter than it normally does. And then the July 13th full moon was also a supermoon. That just means the moon is closest in its orbital ellipse, and it also happens to be a full moon. All right, another meteor shower. This one won't be as good. In August, the 3rd supermoon of the year will be August 12th. Perseid meteor shower is one of the best ones. The best meteor shower. It's a lot of people's favorite and top meteor shower of the year. And that'll be in August 12th to 13th, so mark your calendars there. We usually don't do viewing events for those because they're harder to see in the city limits, but it should be cool to see. August 14th will be the best time to view Saturn. Maybe we'll do a viewing event for that because you can see Saturn pretty well in the city with a telescope. And when a planet is in opposition, that means it's the closest that it gets to Earth in its orbital path. And September 16th, Neptune will be at opposition. Neptune's pretty tricky to spot. It's not visible to the naked eye, so you'll need a telescope to see it. And honestly, I've never been able to catch it in my telescope. I don't quite have a good enough one, so may not be able to see that. But if you have access to a really good telescope, it could be worth checking out. September 26th, though, Jupiter will be at opposition, and that's pretty spectacular to see through a telescope. You can see the Galilean moons, the bright moons that Galileo himself saw and tracked their positions in his notebook, and that is the clue that he received to lead him to the conclusion that the Earth goes around the Sun and not the other way around. A couple other minor meteor showers and then a partial solar eclipse. This one will be visible over Russia. So if anybody feels like traveling to Russia in October this year, then go for it. And then we've got a total lunar eclipse also visible throughout eastern Russia, Japan, Australia, the Pacific Ocean, and parts of North America. Let's see. So we might be able to see this. It looks like this might be, this will probably be a early morning eclipse, so we may not do a viewing event for this one, but you could come out early in the morning to check that out for sure there. Or late at night maybe, 11 o'clock or, yeah, 11 o'clock Universal Time. That should be, yeah, that'll be really early in the morning, like 4 a.m. So you might be able to spot that. And another total lunar eclipse. Looks like there aren't any solar eclipses visible in Kansas City this year, unfortunately. And December 8th, Mars will be at opposition, so that could be fun. We haven't really been looking at Mars much recently, so that could definitely be something to mark on the calendar. All right, so that's a little overview of some of the celestial happenings happening this year. Let's check into the comments. Remember, this is a live stream, so if you have any questions or comments or want to let us know where you're watching from, be sure to head over to the comment section. If you're watching us on Union Station's Facebook page, also head over to the Planetarium's Facebook page to like and subscribe there. That's facebook.com/KC Planetarium. Let's see. We've got Elliot, who's 7 years old from Neosho, Missouri, watching. Thanks for watching, Elliot. We've got Jonathan, who says, what website were you on? So I was on csky.org. That has that astronomy calendar. That's the one I typically use every year. Susie, I heard something about an asteroid coming into our atmosphere. Uh-oh, Susie. And no big asteroids that I know of, but we'll talk a little bit about that later in our news update, because there's a mission that NASA sent to an asteroid to potentially redirect it. It's not crashing into the Earth, but it is sort of a proof of concept mission to prove that we could maybe redirect an asteroid. So stay watching, Susie. We've got Anne saying, well, we've got Granny watching, saying hi from Granny. Granny, thanks for watching tonight. Hope you're enjoying tonight's stream. Emily is watching while cooking dinner. Can't miss your live streams. Well, thanks, Emily. I'm glad you're watching as well. All right, Eric says, for a supermoon, does that mean all the phases share the super characteristics? That's a good question, Eric. And not quite. So a supermoon is just when the full moon is at its closest, is when the moon is also, I'm tongue-tied here. So a supermoon is when the moon is both full and at its closest orbital point. Basically, when the moon is not full in that phase cycle, but like a gibbous or a crescent, it won't be that close. There are moons that are close in that closest point in their elliptical orbit that aren't full, but they're just not exciting. They don't really appear any different. So supermoons are just the exciting ones that are very bright and very close. And we've got Trey saying, what's up, Patrick? Well, thanks for watching. That's another returning watcher. I recognize that name. So glad you're joining us. Hope you had a wonderful new year. Hope you enjoyed today's stream. All right, well, I'm like one bullet point into my notes, so we need to continue on here. An exciting thing happening right now, and could be potentially happening and continuing in the near future, is Comet Leonard. You may have heard there is a visible comet up right now. Here's an excellent picture of Comet Leonard. It is right now at its closest approach to the sun, which generally means that it's at its brightest. That bright tail comes from material being sublimated and basically melted by the sun as the comet gets really close to the sun and whizzes by. So you might be able to see it. If we scroll down here, it will give us, so there's the comet's approach, and as it passes by the sun, it's a very fast comet. It will not be returning. It will exit our solar system when it passes by, so you don't want to miss this one. Here we go. So got January 3rd. There, Comet Leonard will appear sort of next to Jupiter and Saturn, which I'll touch on when we get to our star tour portion. But this will be just barely visible to the naked eye, and not quite as good as the comet we had a couple years ago, but still pretty cool that there is a bright comet. It's just some glamour shots of this comet. Now, that's a pretty amazing picture there. By the way, we did a live stream about comets quite a while ago. That would be our July 13th live stream from 2020. That was our 31st live stream. So youtube.com/kcplanetarium. I made a comet using materials I got from the grocery store in my living room. So that was a very wacky live stream. Definitely want to check that one out. So anyway, Comet Leonard is passing by right now. Now, as the comet passes around the sun, sometimes it gets completely vaporized. We won't see it anymore. But occasionally, it'll come out the other side and still be really bright, or maybe even brighter. All right. So let's return to our night sky tour. If you watched our Stars of Faith presentation at the planetarium, I'd love to hear that in the comments section. Let us know if you checked that out. That was a special one-of-a-kind star tour that we did during the holiday season at the planetarium. We talked about different ways in which astronomy connects with faith, talked about the Star of Bethlehem, talked about the Hebrew lunar calendar, and a few other topics from other religions. So that was a lot of fun. But we're going to be going back to our regular star tour, and we'll be checking out our winter skies, our January skies, which we'll see right now. I'm going to check into the comments because Taylor is asking if Comet Leonard is still visible. Thought it was out of sight by now. What's the best time to see it in Wichita, Kansas? Well, it may or may not be visible. It's going to be setting in the west. In fact, we can see where it is. Let me, first of all, bring a, there we go. Bring a lower horizon view, taking away our Kansas City skyline. So if I fast forward time here and make that sun set a bit more quickly, we can see 3 planets up right now, and those are the planets. Well, Mercury will be just barely visible, but then we also have Saturn and Jupiter that you'll be able to see as the sun is setting. You can tell that they're planets because they're not twinkling. Stars twinkle, but planets don't. So Comet Leonard should be right around here. Now my software may or may not, I don't think it's got comets, unfortunately, but it should be like right around here, right around sunset. So it might be hard to spot because the sunset, the glow from the sun will still be kind of in the way. So it might be hard to see. And like I said, once it slingshots around the sun, it may still be visible or it may not. Trey's saying, have you watched Don't Look Up yet on Netflix? I haven't. That's still on my watch list. I hear it's a bit depressing, but I know it's supposed to be a very good movie with a great cast, so I'll definitely check it out. Oh, Dee Dee's tuning in and says, Happy New Year. Right back at you, Dee Dee. Thanks for watching. So back to our star tour. As I was mentioning, these planets are setting in the west tonight. You'll be able to see Jupiter after the sun has set, and Saturn will be very close to the horizon there. I wanted to focus on a few constellations rising in the east this season, though, because there's quite a few interesting features in our winter skies arising around this time of the year. We'll start with Orion, Orion the Hunter, the brightest constellation in the night sky. You might recognize Orion's famous belt outlined by these 4 stars here. Here are Orion's shoulders, and here are his feet. This little cluster of stars is Orion's head, and he's kind of holding a shield or a bow in one hand and lifting a club or a sword in the other. Let's see if I can... There we go. All right, so there's Orion. Orion represents Orion the Hunter from Greek mythology. He was a famous hunter who angered the goddess Artemis by boasting about his skills as a hunter. Artemis was the goddess of the hunt. There are a few bright stars in Orion. We have Betelgeuse, the bright red star in the upper corner, and Rigel, the star in the lower right. Rigel is a blue supergiant star. It's only about 7 to 9 million years old, which is very young for a star. Our star is about 4 billion years old. It's very young, and it will likely explode into a supernova soon. And by soon, I mean in the next few million years, so we might not witness that. Another bright star is right here, rising below Orion. In fact, if you draw an imaginary line through Orion's belt, it points at this star. And this is the brightest star in the night sky. Its name is Sirius. Sirius is part of Canis Major, the big dog, who along with Canis Minor, the little dog, were Orion's hunting dogs. This is where the term dog days of summer comes from. In the summertime, you'll see Sirius rising in the early morning sky. By the way, if there are any Harry Potter fans watching, it might make a little more sense to now why one of the characters in that story is named Sirius, the dog star. And that's not the only reference from the night sky that J.K. Rowling incorporated into the books. This star in the corner of Orion is named Bellatrix. That name might ring a bell. And there's also a star named Arcturus and a star named Regulus, who are all members of the Black family. All right. Now, below Orion's belt is a group of 3 dimmer stars. Some people call this his dagger or his sword hilt. In reality, this part of the constellation hides a deep space object called the Orion Nebula. Now, this is a flat picture of the Orion Nebula, but we can do better. We can use my 3D planetarium software called Space Engine to visit the Orion Nebula. Let's fly over there now. So the Orion Nebula is a giant cloud of gas and dust containing the remnants of supernova explosions, so stars that died billions of years ago and left their scattered elements out in space. Over millions of years, this gas and dust floats around until gravity pulls it back together, and as these new balls of gas form, they start to get heavier and heavier and hotter until they reach a point where they are able to reignite stellar fusion and they once again become stars. This is the process how all stars are born, this death and rebirth cycle, and it's how our sun was born. And once those stars are born, there's oftentimes leftover material floating around that can form planets, just like Earth. And just like Earth, those planets may even form life. So, everything that our sun is made out of was created by a star that died a long time ago. Everything that the Earth is made out of was also created by a star, and in turn, everything that you are made out of, every element in the human body, was forged in the core of an ancient star that died billions of years ago. So in a very real and scientific sense, we're all made of stardust. That's why I like talking about the Orion Nebula. It makes me feel connected to space in a very big way. All right, let's zoom back out here. Let's check out this star here is named Capella. I haven't talked about this in a star tour yet. It's the 6th brightest star in the night sky and the 2nd brightest star that's up right now, so it'll stand out. It's part of a constellation named Auriga. This is a lesser-known constellation. It is the Charioteer. Visible in the north during the winter, Auriga is often tied to Erichthonius, a legendary king of Athens and son of Hephaestus, the god of fire and metalworking. Erichthonius was rejected by his father, but raised by the goddess Athena, who taught him how to tame horses. He then became the first person to harness 4 horses and a chariot. Some older legends state that Auriga was a goat herd and patron of shepherds as well, which is why he's often depicted as herding goats. So there he is with a goat. I wanted to point out Auriga there and Capella, and you'll see a bunch of bright stars over here in the west in the wintertime. Now, I've talked about the summer triangle before, which is a star pattern that pops up in the summertime. It was used by ancient people to figure out the changing seasons. But that's not the only seasonal shape. In the winter, there is a winter hexagon, which I don't think I have as a line art here in Stellarium, but I can kind of trace it out for you. It's made of 6 stars. One of them is Capella. Another one is this star down here named Pollux, which is part of Gemini. And then there's Procyon, which is part of Canis Minor. Then we have Sirius. And then we have Rigel and Orion. And then up to Aldebaran, which is the eye of Taurus the bull. And those 6 stars form sort of a hexagon shape in the winter, sort of a wobbly hexagon, but you can kind of imagine that. So that when that shape rises in the east, you can tell that it's winter. Or you can tell when, it gets to be negative 20 degrees wind chill, if you need an extra clue. Andrew's watching and says Sirius is his favorite star to spot in the sky. That's awesome, Andrew. I'm glad you know how to find Sirius. And I'm glad it doesn't take you long to find Sirius. Maybe even just 1 second or 2. Tammy says, does weather, cold or hot, affect constellations, stars, or planets? Tammy, that's an awesome question. Thanks for asking that. The weather does affect your visibility of the night sky. In the summertime, although it's very warm and comfy to be hanging out outside, unfortunately there's a lot of heat radiating off of the ground, and that heat goes up into the sky and through the atmosphere, and that heat causes our view of the stars to kind of become wobbly. It's kind of how, like, if you've ever looked around fires, like campfires or even candle fires, you see the light wobbling a little bit. Well, that distortion is in the atmosphere during the summertime as well. So in the wintertime, although it's very chilly and uncomfortable to go stargazing, especially if you're handling metal equipment like a telescope, believe me, the good news is that that's the best time to go stargazing because there is less atmospheric distortion from heat radiating off of the ground. So Tammy, absolutely, the hot and cold weather does affect your view of constellations and stars and planets as well. And winter is the best time since there's less atmospheric distortion. Taylor says, do you believe there is another planet out there somewhere in the universe that has human life? Taylor, that's a great question. Human life, probably not. I bet there is life out there, but it probably doesn't look anything like we would imagine. We're used to life here on Earth that all evolved kind of in the same way and also needs the similar things like water. But there could be life out there in the universe that doesn't need water, or life that's based on other things. Like our life is carbon-based. Maybe there's silicon-based life out there in the universe that looks so different we might not even recognize it as life. But I think statistically there has to be life out there. There's just too many planets. Eric says, when does the sun in our solar system form, or when did the sun in our solar system form relative to the start of time and matter after the singularity based on theories? Just wondering how many star formation and destruction cycles have passed. Ooh, that's a good question, Eric. So how old is our solar system and our sun compared to the age of the universe? Well, the universe is about 13 billion years old, and our sun is about 4 billion years old. So our sun formed pretty late in sort of the age of the universe, and there have been a lot of cycles of star birth and death. Typical main sequence stars, like our sun, will live about 10 billion years. So by the time our sun formed, there could have been entire galaxies of stars that grew and ignited and burned out before our star even came to pass. And this is also assuming that the universe began at the Big Bang. We don't really know if that theory is true. But that's a great question, Eric. Thanks for asking. All right. One other thing I wanted to point out in the night sky is above Taurus, this bright V pattern there, is a little cluster of stars called the Pleiades cluster, or Seven Sisters. Most people can see 6 to 7 stars there with the naked eye. It almost looks like kind of a miniature dipper. We can visit that in Space Engine, though. Let's go over to the Pleiades cluster. So this star cluster is an open star cluster that actually contains about 2,000 stars, and these stars are all baby stars. They were all born from the same nebula. So this is kind of what the Orion Nebula may look like in a few 100 million years after it's formed all the stars. There's some leftover gas and dust, but it's not creating its own light. It's just reflecting light. So the Orion Nebula is an emission nebula. It's so warm and hot that it's creating light. But the Pleiades cluster and its nebula surrounding it is a reflection nebula. It's only shining because it's reflecting the blue light from its young stars. So there is the Pleiades cluster. All right, so there's our little tour of the night sky, folks, for our live stream. We're going to check into the comments section, but stick around because we're going to be going over some current events, and we'll be doing our deep dive for the month, which will be into the James Webb Space Telescope. So you'll definitely want to stick around for that. I've got David in the comments, though, one of our longtime watchers. Hey, David, thanks for tuning in. David says, I have an astronomy question of something I've been pondering. It seems that the Earth's rotation slows by around 1 millisecond per year, and that may be because the moon orbits in the opposite direction of the Earth's rotation, causing a small resistance from its gravitational pull. At this rate, the Earth would stop rotating in around 90 million years. What would happen then? Would the moon's orbit ever slow down as a result of this type of change or continue orbiting for eternity? Ooh, that's a complicated question, David, but that's a great one nonetheless. And that is something we'll need to investigate a little bit here. I'm going to pull up Space Engine again here. And now, there are a lot of different forces in play here. The moon is pulling on the Earth and the Earth pulling on the moon. One interesting thing, though, is that because of the tides, the moon's orbit is actually getting further away from us by about 1 inch every year. So let's go back to the Earth. Fly on over here. So there is the Earth. Oh, I think I turned the clouds off. Not that that really matters. So let's zoom out here. So there's the moon and there's the Earth. Let's speed up time here a little bit. Now, there was One little thing I wanted to correct in your comment, because the moon is actually going in the same direction that the Earth spins. Now, if it was the case, like you said, then those two forces could definitely counteract each other. But as it is right now, the Earth is spinning in the same direction that the moon is orbiting. Let me fast forward a little bit more so you can see that. And this is why the moon orbit is accelerating and getting further away from the Earth. The interaction between the moon causing the tides on the Earth, but then the tides in turn kind of pushing the moon a little bit faster, which expands its orbit and makes it get farther away. As for the Earth's orbit slowing, or the Earth's rotation slowing, it is slowing a lot. In fact, I've talked about this before, but back in the time of the dinosaurs, one day, so one full rotation of the Earth, was only about 20 hours long. And at the very beginning of our planet, it was even shorter. So days have been getting shorter, but at the rate they're getting shorter, the Earth will not stop spinning, or the Earth would stop spinning long after the sun has turned into a red giant and enveloped the Earth in its orbit. So we don't have to worry about that. We just have to worry about other things like our solar system becoming uninhabitable in about 4 billion years. But I think we'll probably figure things out by then, or human life may not even look like it looks like today. But that's a great question nonetheless, David. All these things are interacting with each other. And I believe I've talked about this in past live streams. I've talked about seasons in space-time. That was on September 21st, 2020, where I believe I talked a little bit about these different cycles of the Earth. And the Earth is not just slowing in its rotation, it's also wobbling, and its orbital shape is changing around the sun. These different cycles are all interacting, and it's kind of hard to predict these things so far out. But that is a great question nonetheless. Thanks so much for asking. All right, Susan says, are there seasonal planetarium shows coming up? Love my visit there. Susan, thanks for asking. I touched on this a bit earlier, but absolutely, we are reopening to the public on January 8th, this coming Saturday, with a schedule featuring shows Tuesday through Sunday. The first public show during the week will be at 11 a.m. We've got our seasonal Star Tour Sky Station Live, which is available once a day during the week and twice a day on weekends. And then, of course, we've got many other documentary shows, one about dark matter coming up, one about Mars, and we've also got kids shows, Big Bird's Adventure from the Sesame Street studio, and Magic Tree House based on the kids' book series. So be sure to check those out for sure. All right, Taylor says, do you have a favorite space movie? Mine is probably Interstellar. Taylor, that's a great question. I don't know what my favorite space movie is. In recent years, I saw Ad Astra, which was, I think, an underrated movie that kind of flew by the wayside. I'd recommend that one for any space fans out there. I also like a lot of funny science fiction, like Galaxy Quest is a classic one. I've talked about movies in space, or space movies, a couple times in past live streams. I'm just trying to look up some of those. I did one way back on July 20th, 2020, as well as January 18th last year, 2021. YouTube.com/KC Planetarium has all of those curated in a playlist for you. Yeah, Interstellar is a great one too. I love how it's a beautiful story with some really amazing and accurate visuals. That was one of the most accurate depictions of a black hole in the movies. But thanks for asking, Taylor. David says, thanks for the corrections. I had some inaccurate information that I based my initial assumptions on. Thanks for the answer. No worries, David. I'm glad you asked, and there are other moon and planet systems that do have opposite orbits. For example, many of the minor moons of both Jupiter and Saturn orbit in the opposite direction that their planets are rotating. But that's mostly because they're captured objects, so asteroids and comets that were passing by those planets and were captured by the gravitational field. But in general, most moons will be created rotating in the same direction that their planets are rotating, and that's just because of how the sort of three-dimensional physics works and how many moons were formed in the early days of our solar system. Michael says, where's the best place to stargaze in the USA? And there are many places near you that you can check out. If you go to your favorite search engine and search for dark sky map, you can find a bunch of sites. I won't endorse anyone specifically, but if I click on one, you can see there are many resources you can find for things like light pollution maps showing you where nearby you can find patches of the sky that are not obstructed by light pollution. So Michael, do a little search on your favorite search engine for dark sky map. There's also apps on your phone you can download too. But you can see here in Kansas City there are some spots pretty nearby. In fact, I usually, if I'm feeling like going pretty far away, I'll go drive down here. There's a little town called Eureka, Kansas that has some pretty great dark sky spots, but you can see in western Kansas there are some even better spots, and then further west you can find some pure dark night skies. Emily's chiming in and says Spaceballs is definitely my favorite space movie. Very educational documentary. Indeed, Emily, indeed. Right. Personally, I'm still excited for Spaceballs 2, The Quest for More Money. All right. Okay, it's 6:35, and we are going to jump into our, if I can find my notes, our our current events. Yes, so we're going to talk a little bit about different current events happening, current events that happened in the past month, but I'm also going to talk about some exciting 2022 space missions and launches. But the most exciting thing that we have to start with, and this will be our mini deep dive for today's stream, is the James Webb Space Telescope. Jordan, if you're watching, I fully accept the I told you so. The James Webb Space Telescope did actually launch. I was kind of unsure if it ever actually would, but win, Jordan. And we all win, because we're very excited that this telescope finally launched. This mission was in the works for almost 2 decades. We were waiting a long time for it to get to space, and it finally did. And it's been, over the past about 10 days, they've been slowly deploying it. So this website here, this is Where is Webb, NASA's website. We can post a link to that ourselves in the comments. But this will show you what's going on with Webb, how far away it is, how close it is to its eventual orbital spot, which will be Lagrange point 2, which we'll talk about later. But it's on its way, so it's been flying out there, and they've already started to deploy it. In fact, some of the most nail-biting portions of the deployment have already happened. They've started to deploy the Sun Shield. So the Webb Space Telescope is very different than its closest sibling, or one of its close siblings, the Hubble Space Telescope. Hubble is orbiting the Earth, very close to the Earth, and it's a visible light telescope, so it looks at light from the visible spectrum. On the other hand, James Webb Space Telescope is an infrared space telescope, and it's looking for essentially heat from space. Now the problem is, if we put the Webb telescope near the Earth, there's a lot of heat from the Earth or the Sun or anywhere close by. There's a lot of interference, and it would not give very good pictures, basically. So we want to send it really far away. And we're sending it to this point called L2, or Lagrange point 2, which let me pull up a picture of. But basically, this will make the telescope not orbit the Earth, but orbit the Sun. But it will orbit sort of at the same time as the Earth. So these are sort of gravitational terms, so points where the gravity of both the Earth and the Sun will be pulling on it equally, so it'll kind of be balanced. Imagine like a mountain where something's balancing at the very top, and if it tips a little bit too far, it falls one direction. If it tips too far, it falls the other direction. That's basically where L2 is. And the Webb Space Telescope will be orbiting at the same time as the Earth. Now this means that the Earth will actually be blocking the sunlight onto the Webb, which is good because the sun's light is, well, there's a lot of heat coming from the sun, and that will affect the optics on the Webb Space Telescope. But in addition to that, there is this giant tennis court-sized sun shield that's a bunch of layers of material that'll be blocking all of the heat from both the sun and the Earth, and it will allow the optics of the telescope to capture images at very low temperatures, not blocked by all the heat from and interference from the sun and Earth. So it's on its way there to L2. It'll take about a month to get there, and over that time it'll be deploying other parts of it. So the sun shield is currently being deployed right now, and then it'll start to put the mirrors out, the primary mirrors and the mirror segments. Now we sent the Webb Space Telescope up in a small rocket, much smaller than the telescope is when it's all unfolded. So we had to kind of fold the telescope up into a small piece. This website's really cool because it shows us all the different steps of the deployment. So you can see the telescope there, all folded up into a very tiny spot there. Right away, we put the solar arrays out so it could start charging up its batteries. And then we extended these sun shields. So the sun shields were folded up, but they extended, and then they had to be like unrolled, basically. And so that's what the Webb telescope has been doing. So there you can see this picture here shows one sun shield starting to be unrolled. And right now we're at the point where they are mostly unrolled, and then they're going to kind of fold outwards because there's actually a bunch of layers of sun shield there. So they have to kind of accordion out And then once that happens, they will take this secondary mirror and kind of pop it downwards. This helps to focus the light captured by the primary mirror, and then they also have to fold the primary mirror out. So there are 18 mirror segments here, and those have to kind of pop out. And this will all take about a month. And then after everything is deployed, they have to start aligning the primary mirror. So each there are 18 mirror segments, these little honeycomb-shaped things, and 126 extremely precise actuators that will subtly bend and flex each mirror into a specific position. And this process will take months to get it all lined up. And we expect at about 6 months from now, we'll finally get some real scientific data, maybe some pictures back from the Webb Space Telescope. So the deployment's going well so far, but there are 50 major deployments and 178 release mechanisms that have to go exactly right for this thing to work. So far, so good. Knock on wood. Everybody cross your fingers and toes. Don't walk under any ladders. And hopefully this will all work and we'll get some amazing pictures. The exciting thing about the Webb Space Telescope is that because it's in the infrared spectrum, we'll be able to look at galaxies that are so distant that they exist at the beginning of our universe. Because remember, light takes a long time to travel to us here on Earth, the farther away you get. And so the farther away we look, the farther back in time we look. And the Webb Space Telescope will be able to look at the first stars that were born right after the Big Bang. So we're going to learn a lot about the origins of our universe from the James Webb Space Telescope. So very exciting to be seeing that all develop. It's been crazy over the past week. So many milestones have been hit, and the excitement will continue. Taylor in the comments says, what are your thoughts on the Starlink satellites? Taylor, that's a good question. So the Starlink satellites, for anybody who doesn't know, are a system that we call it a constellation of satellites that SpaceX, a private company, has been sending into space. The idea is to send hundreds and eventually thousands of satellites up into space that will blanket the Earth. And once the satellites are there, it'll be able to bring high-speed internet access to essentially anybody on Earth. So, Taylor, I am torn because on the one hand, I think it's very important for everybody on Earth to have access to the internet and to information. We live in the information age, and information and knowledge is power. And there are many people in places around the world that could definitely use access to communication and to communicate with the outside world and to receive new knowledge. So I think that mission is a good one. And I think that overall is a good thing. The controversy that a lot of especially astronomers are upset about is that these Starlink satellites, because there are thousands of them that are going to go into space, they could obstruct our views of viewing the night sky as well as astronomical observations here on Earth. And that is true. These telescopes are painted and designed to not be very shiny, to have a low albedo. But they are still shining. They still show up in ground-based telescope observations, and they can block our views of the stars and of deep space here on Earth. And that's a bad thing, because the more blocked our views are of the sky, the less we'll learn about space. So sending telescopes into space is a great solution, but that's really expensive, and it's hard for a lot of different astronomers to have access to those. So I'm torn, Taylor. I really don't know what the answer is. I think it's good that people are trying to bring the internet to more places on the Earth. But I do think it's can be a slippery slope and potentially dangerous if we pollute our night sky with more satellites. And there are ways to observe space through using ground-based telescopes that avoid distortion from the Starlink satellites, but it still is an extra trouble. So my answer is mixed thoughts, Taylor. Jesse says, holy cow. Holy cow related to the James Webb Space Telescope, I'm guessing. We've got Craig watching. If it's going to be in our shadow, how will solar panels power it? Ooh, that's a good question, Craig. Let's pull that telescope back up, and let's see if we can get a better look at it. Let's maybe we'll try to check out video. Don't worry, Ben, I'll just pause through this. This is a video showing the full deployment. So the answer is that there are solar panels on the other underside of that sun shield. So basically, when the sun shield is out, it will be blocking the heat on the optical element, but there will still be solar panels underneath that facing the sun that will be able to get electricity. And the sun won't be completely blocked by the Earth, so there still will be plenty of light for the Webb Space Telescope. So hopefully that answers the question, Craig. Thanks for asking. All right, so 6:45, we're doing great. This might be a long one, folks, but we're just going to go over some exciting 2022 missions that will be coming. First of all, the Space Launch System, NASA's rocket that will be going back to the moon. Its launch has been delayed. There was supposed to be a launch in January, but a malfunctioning computer in one of the 4 main engines of the Space Launch System delays the vehicle's launch to no earlier than March. So stay tuned. That will be an historic launch, though. Again, these rockets are scheduled to take astronauts to the moon, hopefully by the year 2024 or 2025. So again, minor delays there for the Space Launch System. But excitingly, there are a bunch of international missions to the moon, such as the Chandrayaan-3 mission, which is an Indian moon rover that is scheduled to land in fall of 2022. The Chandrayaan-2 unfortunately crash landed onto the moon in actually on my birthday, July 22nd, 2019. So happy birthday me, failed moon mission. But the Chandrayaan-3 is basically the same moon rover that they're just trying to send there again. Third quarter of 2022 is the plan. We've also got the Japanese Space Agency, which will be landing or sending their Smart Lander for investigating the moon, or SLIM for short. April 2022 is the plan here. And the agency, the Japanese Space Agency, says this mission is designed to demonstrate lunar landing methods involving a small exploration vehicle. There's a little picture of the SLIM. So good luck to Japan landing that. We'll be tracking that during our streams, of course. Russia is sending their Luna 25 mission. They've been doing a lot of missions to the moon for a long time. Well, they never landed on the moon with a human. They aim to land an explorer on the South Pole area of the moon in July. So this is the Russian news agency. And this spacecraft will study materials on the lunar surface as well as the outermost part of the moon's atmosphere. So that's right, the moon does have an atmosphere. It's a very thin one, but nonetheless, there is a tiny atmosphere there. So there is the lunar rover, or lander, I suppose. All right, the SpaceX Starship full orbital test is being planned to take place this year. It has been delayed a little bit, though. It was recently pushed back to March at the earliest, pending FAA approval. The Federal Aviation Administration had over 18,000 environmental impact notes for Elon and his SpaceX company over the last test launch. So they're currently looking through those notes and working on making the FAA happy. And that won't be done until the end of February. So hopefully March will be the first orbital test of the SpaceX rocket, which will also be taking people back to the moon. It's part of the Artemis program. So not only is NASA sending their own rockets to the moon, but they are contracting private companies to do that as well. And then we've got the ExoMars mission, which is actually a series of missions that have been taking place. It's a joint European-Russian mission. And there's a rover mission as part of this ExoMars mission that is scheduled to launch between August and October this year. This will put a rover on the surface of Mars to search for signs of possible life. And the rover's name is Rosalind Franklin. Rosalind Franklin was an important researcher in the early 1900s for understanding the molecular structures of DNA, so it's fitting that Rosalind's name will be on this rover looking for life on Mars. So other countries joining the rover expeditions to Mars, not just the United States, always an exciting thing. And lastly, we have the DART mission, which launched in November of 2021. This is the asteroid redirection mission, where we are going to try to bump an asteroid to see if we could protect ourselves if an asteroid was discovered on a collision course with Earth. This asteroid is heading towards this mission, this probe is heading towards the asteroid Didymos, which is over here. Didymos. Whoa, that was a little close. I wanted to turn. It's actually not. I want to keep the orbits on. Okay, I mean to crash into the asteroid. This is actually a double asteroid system. This asteroid has a little satellite, Dimorphos. It's a tiny asteroid orbiting this other asteroid. Very tiny. It's only about 500 feet wide. But basically, the DART mission, which was launched in November, as I said, is expected to reach the Didymos system between September 26th and October 1st. And it will attempt to strike a non-threatening asteroid as a test to see how the crash affects the space object's path. So pretty exciting. In fact, we just got our first pictures back from the DART probe, but they're just pictures of stars. It's not very exciting, sorry. So those are some upcoming exciting missions that will be happening this year. So be sure to stay tuned for those updates. And we're going to cover a couple other exciting news updates that happened over the past month, so stay tuned for that. But I'm going to check into the comment section. Alan says the James Webb Space Telescope orbits L2, so it's always in sunlight. Yes, so always in sun. Is that true? This is, of course, something I should know. I know that L2 won't be quite close enough to the Earth for the Earth to block the sun's light, so that does make sense. It will be in sunlight, but it will still be far enough from the electromagnetic interference of the Earth. So I guess, Alan, that does make sense that it would need some sunlight for its solar panels to operate. So thanks for the correction there, Alan. Audra says, will they be landing when they go to the moon? Audra, that's a great question. So the Artemis set of missions, here's NASA's flashy website about that. We'll be going back to the moon. There have been some delays, of course, because of the global pandemic. But the plan right now is to send the first crewed mission sometime soon. It won't land on the moon, the first one. It will go around the moon. But let's see. So Artemis 1 will be an uncrewed flight test to orbit around the moon, and that's the one that has been postponed. Artemis 2 will be the first crewed flight, and that will be taking place sometime soon. This is a bit of an older article. Let's check the latest launch estimates. So right now, Artemis 2 will be planned on launching in 2024. So this will go back to the moon. It will just go around the moon and won't actually land on the moon. And Artemis 3 will be the landing on the moon, right now scheduled for 2025. So that's been pushed back a year, I know. But hopefully it won't be pushed back anymore. Anne says, how will the sun shield hold up in space? What's it made out of? That's a great question, Anne. So let's find out. So the James Webb Space Telescope sun shield, here's a great article about it. So it separates the warm sun-facing side from the cold non-sun-facing side. It's a 5-layer sun shield, and let's see what it's made out of. Let's see. It's got 5 layers. Why does it have 5 layers instead of one thick one? Each layer will be cooler than the one below it. The heat radiates out from between the layers, and the vacuum between the layers is a very good insulator. One big thick sun shield would conduct heat from the bottom to the top, more than 5 layers separated by the vacuum. Let's see. So here's a close-up picture of it. It's made of a material called Kapton, which is it looks like coated with aluminum. It has treated silicon and I'm sure many other materials. It's probably pretty delicate, but I guess the idea is with a lot of layers, if there is a tiny micro puncture, there will still be enough protection to protect the telescope. So a great question, Anne. The answer is that it's made up of some very sciencey material that I know less about because I'm not a material scientist. But thanks for asking. Jesse says, do the different countries communicate to prevent rovers crashing into each other, or is it BattleBots Mars? Jesse, that's a great question. And the answer is, I'm sure they do. I don't know specifically what their communication network is like, but I do know that there are communication networks that help things like satellites communicate. In fact, my former colleague Jordan, who currently works for NASA, works in their communications department, where they talk to different satellites, which is an amazingly cool job. But I'm guessing they definitely communicate. Now, the good news is that Mars is very big and rovers are very small. So there is very little chance of any two rovers accidentally crashing into one another. It's pretty publicly known where every rover is. So I guess we just mostly don't worry about it. And I suppose that if one country announced that they were going to land a rover right next to one of our rovers, there would be some diplomatic talks and there would be some collaboration there. But I'm sure there is some talking there. Craig says, what is the status of the probe going to the sun's atmosphere? Is it destroyed yet? That is my next topic of conversation, Craig, so thanks for asking. Keep the comments coming, everybody, though. I'm going to put a pin in these comments, and let's talk about the Parker Solar Space Probe. And I have it pulled up right here, actually. This visualization software is called NASA's EYES. This is free software you can download. They also have a web version. It's a cool sort of 3D planetarium software. You can explore planets and stuff, but it also has detailed information about their probes, such as the Parker Solar Space Probe. So we can see this probe up close. The Parker probe has its own sun shield as well. And this is a solar probe, so it's sent to explore the sun. And that means it's going to get very close to the sun. In fact, the exciting bit of news I wanted to update you all on is that back in April, the Parker Solar Probe dipped very close to the sun. We can see it dipping right there. I've rewound time to show that close approach. And you can see it's very close to the sun relative to the other planets. This was the first time it actually dipped into the sun's atmosphere, or corona. These findings were published in December, so we actually saw this sort of data and imagery from this April part of its orbital path. So it, for the first time, entered the magnetically dominated solar corona. And the high temperatures and strong magnetic fields of the solar corona, they form streams of solar wind that expand through the solar system out into interstellar space. On April 28th, this is when the Parker probe passed within 13 million kilometers above the photosphere. This mission is ongoing, so it will continue orbiting, getting closer and closer, touching the sun even more closely. This mission is designed to help us try to understand heliophysics, physics of the sun, how our star behaves. The sun is the closest star to us, so it's the best and easiest one to study. One thing I wanted to show you, there's some cool video of this close encounter. So that's right, there is a video camera on the Parker Solar Probe. We actually got, I'm going to try to show you just a smidge of this, but this is actual imagery of this probe going through the sun's corona, and you can see the outline of the Milky Way galaxy. A lot of what you see here is charged particles touching the camera elements, but this is basically what we're looking at is this probe flying through the sun's atmosphere. You can even see some planets going by. This is obviously very sped up here. You can see the time passing by there. So yeah, those are planets up there. But pretty incredible stuff, actually watching this probe fly through the sun's atmosphere. So thanks for asking about the Parker Solar Probe. That got me into my next topic. So much engagement today. I'm so glad everybody's chiming in and tuning in. So keep the comments coming, everybody. I'll just keep on rolling if everybody's still watching. We've got David in the comment section says, what about China? Do you know what Chinese space missions will take place? I'm sure there are planned missions in the next year. There weren't any that popped up on sort of my feed of big upcoming projects. I think they're maybe a little bit more secretive about their projects. But right now, China is mostly focusing on building their space station. They're working on a Tiangong space station that is sort of competing with the International Space Station. Of course, China has to have their own space station. They also have a moon mission that's going on, which I'm planning on talking about a little bit later. They have a moon rover, a little probe that has kind of a fun mission that it's working on right now. Yeah, let's see. Upcoming China space missions. You can see, you can tell I really prepared for this. Okay, 4 key missions in 2022. China, they're mostly working on their space station. There's the concept of it. They are completing the Tiangong space station basic structure. They are planning on launching rockets from the ocean. I didn't know about that. Oops. I stopped you from seeing that. There you go. So there's the space station artist rendering, Tiangong space station. So they're going to complete that. They're going to try to launch rockets from the ocean. So they're building a ship right now that will be automated and we'll be able to launch rockets from the ocean instead of instead of land, I guess. They're planning a mission to Mars. The Zhurong rover. Let's see. It's already on Mars. I'm sure I mentioned this in a past live stream. Um, yes, yeah. So we talked about this last May during our monthly stream. So it landed. This rover landed on Mars in May. I just haven't heard a lot of exciting science from it. Again, they're probably keeping that a little bit close to the vest, as they sometimes do in China. But this right now they've got a rover on Mars, which is exploring a little bit. So I guess the U.S. is not the only rover on Mars. And then the Moon rover, as I said, is going to be exploring a mysterious hut object, as they describe it. I'll just talk about that right now. It's on its way to this hut object. Basically, back last month, it photographed this little cube-shaped object on the surface of the moon. It's about 260 feet away from the rover, which sounds pretty close, but the rover will still take a few months to get to it. The rover is solar powered, so it can only operate during lunar daytime. Lunar nighttime is 15 days long, so it has to wait for the sun to rise. And it also can't move around during lunar noon because temperatures can reach 260 degrees Fahrenheit. So it will take a while for it to get over to that. It travels about 3 feet on average every day. But it will explore this mysterious object. Perhaps it's an obelisk from 2001: A Space Odyssey, or maybe it's just a rock that's shaped a lot like a square. But thanks for asking about the Chinese space mission. Sometimes those slip through the cracks since they don't pop up on a lot of our NASA-related and internal space news feeds. So thanks, David, for asking about that. Emily says, I know we first went to the moon in 1969, but how many times have we been to the moon since then? Great question, Emily. If we're talking about just crewed missions to the moon, there were 6 successful landings and moonwalks that took place, basically. That was Apollo 11, 12, 14, 15, 16, and 17. That's 7. So wait, 11, 12, 14, 15, 16, 17, 6. I said 6. Right, I can count. This is great. I don't have a degree in mathematics. Anyway, 6 successful landings on the moon. There have been numerous uncrewed probes and rovers to the moon, though. But if we want to keep it very simple, how many times have we been to the moon? Then you can say we've been to the moon 6 times. And then we're planning on going a 7th time, hopefully in 2025 rather. And that will be the... NASA's planning on that being the first woman to walk on the moon as well, because all the guys had all the fun back in the 60s, 70s. D.D. King says Rosalind Franklin died in 1958. Her work on DNA enabled Crick to claim he discovered the structure of DNA. Her work was not early 20th century. Was mid, not early 20th century. You're right, Dee Dee. Thanks for correcting me there. Mid early-ish, I guess. Yes, it was in the 40s and 50s, I believe, or 30s through. She died very young. She died at about the age of 37. So I guess it was around right in the middle of the 20th century. So she is very a lot of her research, the credit for her research was taken by other scientists at the time. So I think in an effort to give her a little bit more credit for her research, they did decide to name the rover after her, which is some consolation, if not complete consolation for her and many other women at the time who were active in science and important for developing important scientific advancements that were glossed over or sort of buried under the rug, and their discoveries. Their credit for their discoveries taken by men in their field, as so often happened at the time. But thank you for the correction, Dee Dee. Jesse says, so eventually Mars will need rover traffic laws to establish right of way. Roger. Yeah, that's right, Jesse. Maybe you can start a whole new area of study for that. There are people who study traffic here on Earth, so I'm sure someday in the future, on a long enough timeline, there will be Mars traffic controllers out there. And Emily says, I like your mug. Well, I like your mug too, Emily. Thanks for giving it to me. All right. So let's see what else has happened over the past month. We talked about the solar probe. Ooh, here's a fun news update that I found. Scientists have found a quote-unquote significant volume of water hiding under the surface of Mars. Inside the Mars Grand Canyon, as they call it, which is the Valles Marineris Gorge, or the Mariner Valley. It's a huge canyon, about 5 miles deep and about 1,000 or 2,000 miles long. This newly discovered volume of water is hiding under the surface of Mars. It was detected by the Trace Gas Orbiter, a mission in its first stage under the guidance of ESA Roscosmos, part of ExoMars. I mentioned that earlier. Let's see. Here's a sciencey picture that could look good in a thumbnail. These signs of water were first picked up by this orbiter's Fine Resolution Epithermal Neutron Detector, or FRIEND instrument. They really love their acronyms. It was designed to survey the red planet's landscape and map the presence and concentration of hydrogen hiding in Martian soil. Basically, where there's hydrogen, some scientists assume there could be water. So they think this hydrogen is bound in water molecules, H2O. As much as 40% of the near surface material in this region appears to be water, said one of their scientists. Several features of the canyon, including its topology, have led the researchers to speculate that the water is probably in solid form, ice, or could be a mixture of solid and liquid. So perhaps future missions to Mars will explore the Mariner Valley there, if that is a place where water could exist on Mars. Always exciting to find water on Mars. We have found water on Mars in the past, so this is not super new news, but still very exciting. Here is something cool. NASA has released an audio clip of what Jupiter's moon Ganymede might sound like. So the Juno probe, which has been exploring the planet Jupiter for a while, has been taking some measurements of Ganymede. NASA's Jet Propulsion Laboratory, that manages a lot of their deep space probes, took some data and basically converted it to they shifted the frequency from emissions collected from electric and magnetic waves produced in Jupiter's magnetosphere, interacted through via Ganymede, the moon of Jupiter. And then they shifted the frequency into an audio range to make an audio track. And I've not listened to this yet, so let's listen to Ganymede, the biggest moon in our solar system, and let's hear what it sounds like. I'm going to make sure our desktop audio is on, and let's see what Ganymede sounds like. Sounds very sci-fi. Wow. If you listen closely, they say you can hear the abrupt change to higher frequencies around the midpoint of the recording, which represents entry into a different region in Ganymede's magnetosphere. It might be a little loud. Turn down a little bit. I hope I'm not blasting everybody's speakers out here. Oh, I think it's kind of a bop. What do you think? All right. Well, there you have it, everybody. Let's bring our background sound back up. So what does everybody think? What does everybody think of the Juno track? Do you think it slaps? I think it's pretty good. So it's kind of silly, you know, taking data that's not really sound data, but turning it into data is more of just sort of a fun thing that NASA does to kind of get people excited about space. You can, you know, use those findings to just look at data in different ways, you know, look at wavelengths or listen to, maybe you can, you know, humans are really good at detecting patterns. So if you listen to those, that data as a sound wave, maybe you could detect a pattern that couldn't be seen otherwise, but it's mostly just sort of fun. As he says, Ganymede's greatest hits. Every techno club will be jamming. I don't know. I mean, it was kind of the beeping going up and down. It kind of sounded like 60s B sci-fi movie, but still kind of cool. Linda in the comments says, hello and Happy New Year to you, Patrick, and everyone else from Belton, Missouri. Linda, thanks for watching. Hope you're enjoying tonight's stream. If you're tuning in late, don't worry. You can watch this recording on our Facebook page or our YouTube channel, youtube.com/KCPlanetarium. All right, let's check in on some fun moon news. A sample from the moon brought back to Earth 50 years ago is going to be opened soon. So there is a container, a sealed and a vacuum-sealed container of lunar soil that was brought back from the Apollo 17 mission, the last mission to the moon, and they are planning on opening that here in the near future. So Apollo mission planners were really smart. They recognized that future scientists would have better tools and richer scientific insights than they did back in those days. So they didn't open all of the lunar samples returned from the Apollo missions. They actually saved a few of them. And so now, 50 years later, we are going to be opening those and hopefully gaining some cool insights into the moon that we didn't have from samples we collected a long time ago. This particular sample was collected by Gene Cernan in 1972, the last person to step foot on the moon. And the European Space Agency is actually going to be, they've got permission from NASA to open that sample. So that should be happening pretty soon. Should be pretty exciting. So the hope is that lunar gases might still be present inside, specifically hydrogen, helium, and other light gases. And analysis of these gases could further our understanding of lunar geology and shed new light on how to best store future samples, whether they be gathered on asteroids, the moon, or Mars. So pretty exciting. Here is a picture of the Apollo can openers, as they're so affectionately called. That'd be a pretty cool job description. I would love to be an Apollo can opener. All right, let's see. I think. All right, great. So I have just 2 more news items to cover about astronomy and deep space. So we're going to be wrapping up our stream pretty soon. We've gone over an hour, which is really exciting, but everybody has seemed pretty engaged so far. The 2 people who are still watching, I have no idea how many people are still watching, but we will be ending soon. So if anybody has any last-minute questions or comments, now is the time. Put those in there and explore the final couple news stories for this month. The first one I'm going to talk about is this is a paper published in the Journal of Nature. And basically, this paper talks about how astronomers have spotted 170 potential rogue exoplanets, which is the largest batch yet. Let's actually see if I can get Oh, of course, you have to pay to read this article. Gotta pay for science. That's okay. But basically, rogue exoplanets are just about as creepy as they are mysterious. Should have talked about them in my Space Mysteries stream. But they're basically planets that are floating out in space without a star. So they're planets that are dark and don't have any star that they're orbiting. And that also means that they're really hard to find. We first learned about them in the 1990s, but there are so many unanswered questions about them, the conditions in which they form, their size and composition, and how many of them there are in the galaxy. So a team of scientists, they spotted upwards of 170 rogue planets in a nearby region of the Milky Way, known as the Upper Scorpius Stellar Association. And by nearby, we're talking about 420 light years away. Nice. This effectively doubles the total number of known free-floating planets, a sign that the total population of rogue planets in our galaxy is huge, much bigger than we originally thought. Some scientists think that the number of rogue planets floating around without stars in the Milky Way, our galaxy, could be in the billions or even trillions. So these were discovered by scientists who were actually poring over data that's about 20 years old, looking for observational data that we might be able to gain new insights into. And they used a new technique for detecting faint heat signatures from Jupiter-sized rogue exoplanets. So this total number of objects observed in this study exceeds the number of free-floating planets expected if they only form like stars from the collapse of nearby molecular clouds, as one scientist said. Basically, what's that saying is, we used to think that these rogue planets formed just by material floating around that kind of coalesced via gravity, just like material that forms stars. But because there are more planets than we originally thought, this could suggest that these planets were actually the result of ejections. So planets that were actually flung out of their solar systems due to the interaction of another massive gravitational object. We've messed around with this software called a Universe Sandbox, where we can mess with 3D physics and kind of send other objects through our solar system. And basically, imagine if another star flew through our solar system far enough away that it didn't, blow any planets up, but close enough that its gravity pulled the Earth away from our sun. There's actually a great short story about this. It's called A Pail Full of Air, which is it a pail? A pail full of air? Let's see. A Pail of Air. Yes, it's a short story by Fritz Lieber, published in 1951 issue of Galaxy magazine. It was also dramatized into a radio show in 1956. You can put it online for free, to believe. It's here's the Internet Speculative Fiction Database that has a copy of it, I believe, and you can also listen to it. Oh, here we go. Awesome. So I'm gonna post a link to this because this is a great short story. But basically, it's a science fiction short story about what if the Earth got pulled away from the sun and things got very cold. A very, very fun short story to check out. One of my favorites. Pail full of air. Anyway, all that to say, these rogue exoplanets could be planets like Earth that were ripped away from their parent stars. Pretty crazy to think about. All right. And I see we have some comments, but I'm just going to bring up our final story. So last chance to put any comments. We'll check in on those before we finish. But here is my last story. And this is a sort of more of a speculative idea that some scientists have come up with. But basically, scientists have led a study that suggests a method that we could travel to another solar system in a very short amount of time. So their idea is to use a light sail powered by millions of lasers that could send a probe from our solar system to the nearest solar system in about 20 years. The nearest solar system the nearest star system is Alpha Centauri. It's about 4 light years away. So a probe that could get there in 20 years would be traveling it at relativistic speeds. So speeds at a significant fraction of the speed of light. So this is called the Breakthrough Starshot Project. And their idea is to design an ultralight spacecraft which acts as a light sail to travel an unprecedented speed, tens of trillions of kilometers within 20 years. So the idea is to make a giant sail and essentially shoot over 100 million lasers at this sail to use optical power to basically push this probe and accelerate it near the speed of light. We've actually tested this out in the real world back in 2019. There was a Carl Sagan-inspired project called Light Sail 2 that was able to successfully lift an orbital trajectory of a satellite by about 3 kilometers using a light sail or solar sail propelled by photons from the sun. So there's precedent here, and there's real science to suggest this could be possible. The next step is to start testing some basic building blocks in a controlled laboratory setting, but it's exciting to think that perhaps in some of our lifetimes we may actually be able to send a probe to and from a distant solar system or a distant star system like Alpha Centauri. If we sent a probe today, it could reach there in 20 years, and then if it sent a signal images back to Earth, it would take about 4 years. So this whole process could take only about 25 years. So if this manages to get off the ground, this mission, then perhaps we'll be able to see Alpha Centauri. Although, if anybody's read the three-body problem, that may be a star system we don't want to mess with. All right, some final comments before we end. We've got Anne who's asking, since we already went to the moon and got samples, what are we looking for in this new mission that we didn't already find out? Great question, Anne. I touched on that a little bit, but basically the instruments that we originally used to study the lunar samples were from 50 years ago. And so we have improved our methods of science detection since then. And so the hope is that we'll be looking at lunar gases. So these are sealed samples, so vacuum sealed capsules that hopefully have captured some gas from the moon, kind of like Antarctic ice core samples. So when scientists take core samples of the ice in Antarctica, what they're really interested in is studying gases trapped in that ice to learn about the atmosphere of the Earth hundreds or thousands or millions of years ago. And so this could be like a core sample from the moon. We learn about gases that were from the moon, and this will help us to understand the geology of the moon. But really interestingly, though, it could help us for future missions when we're gathering samples from, say, asteroids or Mars. Great question, Anne. Jesse says, why is the Parker footage in black and white? And the answer, Jesse, I'm sure, is that the Parker Solar Space Probe, its instruments are very lightweight and very small, and so we probably didn't send like a high megapixel camera up there. And also, their instruments are designed to take a lot of abuse that probe is so close to the sun, we're probably only able to get black and white footage. Any more delicate sensors could be blown out by all the radiation from the sun. So that's my guess, Jesse. We can look up the information about the Parker probe. Here is its website. Ooh, that's a cool website. I haven't seen that before. But we can look at the instruments on the Parker solar probe. And so the wide field imager right there is the one that takes the images. Doesn't have a ton of information, but I'm guessing it's just a very small and, again, as lightweight as possible instrument, so we don't want to send color cameras up there. And that's often the case for a lot of probes, even probes we send to places like Mars. The way they're able to capture color images is using filters, and we have algorithms to combine different images to sort of pull out the color data without sending like an actual color camera. A great question, Jesse. And then our final question of the night. Craig says, space movies were mentioned earlier. Sunshine is a space horror movie that's worth a watch. Some beautiful visuals. Absolutely, Craig, that's a great movie to watch, and definitely a good horror movie. I don't think I've talked about that in any of my past live streams, though, so I might have to mark that down for a potential future Hollywood live stream. There are so many movies I didn't cover in any of my past Hollywood live streams, but Sunshine's a great one for sure. Also a great movie about space craziness. So definitely worth a watch. Also, if you enjoy movies like 2001: A Space Odyssey, it's a good hard sci-fi movie, but it also kind of gets a little esoteric towards the end as well, in a good artistic way. But yeah, thanks for that point, Craig. Folks, this brings us to the conclusion of this pretty long live stream. I hope everybody who's tuned in this long has been enjoying tonight's stream. I know I have. We've covered a lot of fun topics. Don't forget the planetarium will be reopening to the public this Saturday, January 8th, with a schedule featuring Tuesday through Sunday shows. Our live star tour will be back. Documentary about dark matter. You don't want to miss that. Phantom of the Universe is one of my favorites. Worth checking out for sure. Also, don't forget to like and subscribe to both the Planetarium's Facebook page, that's facebook.com/KCPlanetarium, as well as our YouTube channel, youtube.com/KCPlanetarium. There you can find all of our past live streams, so for first-time watchers who tuned in, if you want to check out any of our past shows, we have a bunch of great content last year and the year before when we did hour-long deep dives into specific topics. There are a lot of fun topics that we covered then. And then all of our past monthly live streams have been fun too, if you want to catch up on some cool space news that's happened over the past year. Yeah, thanks again, everybody, for watching. Thank you to our supporting sponsor, MRI Global, once again for supporting these programs. I have been your planetarium guy, Patrick Hess, Planetarium Manager at Union Station. Thank you for watching this live stream. Happy New Year, everybody. I hope this year starts off great for you all, and I hope to see you all under the stars at the Planetarium or next month for our next monthly live stream, where we will be checking out everything that happened in the month of January. That live stream will be on Monday the 7th, the first Monday of February. So we'll see you then. For now, everybody, have a wonderful night. Thanks again, y'all, and we will see you next time.